Hello, this is Mr. Brooks, and welcome to Chapter 4, Lesson 4.1, Congruent Figures. In this lesson, we are going to recognize congruent figures and their corresponding parts. First, let's talk about congruent figures. Congruent figures are simply figures that are same size, same shape. Now, congruent polygons have to have congruent corresponding parts so that their sides and their angles are going to match up. And as you already know, always list corresponding vertices in order. So if we call this polygon ACBX, then we have to name the polygon on the right polygon PRQY, because the A corresponds to the P, the C to the R, etc. So angle B corresponds to angle Q, and segment AX corresponds to segment PY. Now if you look at example 1, triangle TJD is congruent to triangle RCF, you can certainly see you got 3 pair of sides that all are congruent to the 3 pair of sides of the second triangle and the 3 pair of angles that are congruent. How would you do quick check number 1, even though they don't show either triangle? First begin by telling me which angle corresponds to angle W, and which one corresponds to angle Y, and which one corresponds to angle S. I certainly hope you would say angle W is congruent to angle M, and angle U is congruent to angle K, and angle S is congruent to angle V. Now match up your 3 pair of corresponding sides. Please pause the video while you try to figure out which segments correspond to the given segments, the black, red, and the blue. Hopefully you will agree that segment WU corresponds to segment MK, and segment YS corresponds to segment KV, and segment SW corresponds to segment VM, not MV. Make sure your S corresponds to the V, the third one to the third one. I'm sure you figured out twice when I said U, I meant Y. Sorry. Now let's look at example 2. These 2 pentagons are example of the fins of the space shuttle. How would we get the measure of angle B? First, I hope you would agree that angle E is going to be congruent to angle B. All right, that these 2 pentagons are congruent. So if we figure out angle E, we're going to have angle B. Question is, how are we going to get E? Please pause the video while you try to figure this out. Hopefully you remember that the sum of the interior angles for any convex pentagon is going to be n minus 2 times 180, which is 5 minus 2 times 180. So 3 times 180, which is 540. So we know 4 of the angles, so we're going to add those up and subtract it from 540. Angle P is 90, and angle A is 90. So we're going to add 90 plus 90 plus 88 plus 132. And that gives us 400. So we subtract that from 540. The remaining angle, measure of angle E, must be 140, which is also the measure of angle B. Now let's take a look at example 4 and see if we can get these 2 triangles to be congruent. Hopefully you agree segment AC is congruent to segment EC because they both have 1 tick mark on them. Segment AB is congruent to segment ED because they're both 3 units long, and segment BC is congruent to segment DC because they're both 4 units long. We can also see angle B is congruent to angle D because they're both right angles, and all right angles are congruent. Angle A is congruent to angle E because they both have 1 arc on them. The question is, how can we get our last pair of angles congruent? Angles right here with the 2 blue arcs. How do we know those angles are congruent? The last pair of angles, angle ACB and angle ECD, are congruent. Hopefully you realize because of VAT, vertical angle theorem. Now we can say triangle ABC is congruent to triangle EDC. Hopefully you see that since all 6 pair of corresponding parts are congruent, the triangles have to be congruent. All 3 pair of sides are congruent, all 3 pair of angles are congruent. And notice how I matched up all the corresponding vertices every time I have a congruent statement. Now let's try quick check number 3. See if we can get these 2 triangles congruent. We know angle J is congruent to angle M because they both have 1 arc on them. We know angle K is congruent to angle N because they both have 2 arcs on them. And angle JLK has to be congruent to angle MLN because of vertical angle theorem. Oh, now notice how I always have the J correspond to the M and the K correspond to the N. Those 2 points correspond to one another. But do we have any pair of corresponding sides congruent? No, in the opposing triangles, no. They've got 2 pair of sides in the left triangle congruent and 2 pair of sides in the right, but we don't know any pair from the left triangle congruent to the triangle on the right, so we cannot say these 2 triangles are congruent. Our first theorem in chapter 4 states if 2 angles of one triangle are congruent to 2 angles in another triangle, then the third pair of angles must also be congruent. Using our symbols, we will write if 2 angles of one triangle are congruent to 2 angles of another triangle, the third angles are congruent. Follow along with example 4, our first proof in chapter 4, while I talk you through it. As you can see, you've got 2 pair of sides that are given to be congruent. Segment PQ is congruent to segment PS, and segment RQ is congruent to segment RS because they both have 2 tick marks on them. All right, the middle segment is going to be congruent to itself by reflexive property. Anything is congruent to itself in this class by reflexive property. We also can see angle Q is congruent to angle S, given because they both have 1 arc on them, and angle QPR is congruent to angle SPR because they both have 2 arcs on them. Now, what else do we need for the triangles to be congruent? We are going to need these angles down at the bottom to be congruent in order to get the triangles congruent. And we can say those angles are congruent because, don't use theorem 4.1, we would have to say if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles are congruent. That's our reason for step 4. And now we can say the triangles are congruent because we've got all 6 pair of corresponding parts congruent. Now let's look at quick check number 4 and see if we can prove these 2 triangles congruent. Well, you've got 2 pair of angles that are congruent. Angle A and angle D both have 1 arc on them. And angle E and angle C are congruent. They both have 2 arcs on them. And you got 3 pair of sides that are congruent in blue. Question is, how are we going to get these 2 triangles congruent? Please pause the video while you try to figure this out. Hopefully you realize you need your last pair of angles to be congruent. Angle ABE, with 3 arcs on it, has to be congruent to angle DBC, with 3 arcs on it. How are we going to get those 2 angles congruent? Vertical angle theorem says all vertical angles are congruent. Now that we've got all 3 pair of angles congruent and all 3 pair of sides congruent, we can say what we're trying to prove, that triangle, let's say I call this triangle EBA. How must you name the triangle on the right? If I call the one on the left EBA, you better call the one on the right CBD. E corresponds to C, the B's correspond to one another, and the A corresponds to the D. And why can we say this? Our reasons are always definition, postulates, or theorems. That would be definition of congruent triangles. All 3 pair of sides are congruent, and all 3 pair of angles are congruent. This concludes lesson 4.1.